There is one kind of function where we'll always have a straight line when graphed, no twist or turns. Hello math learners, Hassan here, ready for another journey through Algebra 1? Today we're jumping into the world of linear functions. Okay, so let's start this topic, linear functions. Linear function is a function with a constant rate of change. If there is no constant rate of change, that function is not linear. Now we can have several different ways to represent a linear function. We can have word form, we can have equation or function notation, we can have tabular form, or we can have graphical form. Let's look at this scenario over here. Suppose a maglev train travels a long distance and maintains a constant speed of 83 meters per second for a period of time once it is 250 meters from the station. Let's see what are the information we can gather from this problem statement. If we want to describe this function in word form, we can say the train's distance from the station is a function of the time during which the train moves at a constant speed plus its original distance from the station when it began moving at constant speed. Let's see how we can write these in equation or function notation. When written in equation or function notation form, we typically use y equals mx plus b form. So in this case, we can say that y is our output value, x is our input value, and this m represents the constant rate, and this b represents the initial or original value. Now let's see how we can combine this word form and the equation form together to create a linear function. So for this, we'll be using y or d of t as the output value. So we have y equals mx plus b as the main equation form. Now for the output value, we can use d of t. Remember, d of t is representing the train's distance from the station. Since the train's distance from the station is a function of t, time, so you can use this independent variable as t. Now this m represents a constant rate. From this problem statement, we can see the constant rate is 83 meters per second. So you can write this as 83 over here. And the train is originally 250 meters from the station. So it's 250 for b. So our linear function is d of t equals 83t plus 250. Remember, we can also write this as y equals 83t plus 250. Now this is the function for this problem statement. Now we can form a table of values from this linear function. We know that d of t is 83t plus 250. So we can plug t equals 0. So once we plug t equals 0, we get 83 times 0 plus 250. That simplifies to 250, and we get 250 over here. If we plug t equals 1, we get 83 times 1 plus 250. So we get 83 plus 250. That is 333, which is right over here. So each time we can see that the function is increasing by the magnitude of this constant rate, 83. So from 250 to 333, we are just adding 83. Again, from 333 to 416, we are adding 83. And from 416 to 499, we are adding 83. Now let's look at the graph for this function. Once we have the table of values, we can simply plug in the coordinates. 0, 250 is right over here. Remember, this is the input-output relationship. We can write this as 0, 250. The next one, we can write 1, 333. The third one, we can write 2, 416. And the last one we can write as 3, 499. So we have this first point over here, 0, 250. The second one is 1, 333 right over here. This is the third point right over here. And the last point is right over here. Once we have this, we can just connect them with a straight line. So this is the graphical form of this linear function. Let's do a quick knowledge check over here. Can a vertical line be a linear function? If we look at any vertical line, can this vertical line be a linear function? So the answer is simple. We can apply the vertical line test. Does it touch only once or more than once? So let's see over here. If we apply a vertical line test over here, let's say this is the vertical line, and we can see that this vertical line overlaps the black line. So it touches more than one point. Actually, it touches at all points. So this vertical line cannot be a linear function. So remember that any vertical line on the graph cannot be a linear function. So here is a quick note. Linear function is a non-vertical line. Now we'll see types of linear function. We have three types of linear function that we'll see over and over again. One is increasing function, another is decreasing function, and the last one is constant function. Increasing function is the one where the y value will increase as we go from left to the right. And the decreasing function is the one where the y value decrease as you go from left to the right. And the constant function is the one where the y value will just remain constant as you just go from left to the right. So the y value would not increase or decrease. It will just remain flat. So this is termed as the horizontal line. You can see that we don't have any vertical line over here because vertical line is not a linear function. So here is a quick summary of linear function. A linear function is a function whose graph is a line. If we cannot have any line on the graph, this cannot be a linear function. For the linear function, we can write the slope-intercept form, which is y equals mx plus b. This slope-intercept form will be explained in details in the upcoming videos. In this case, this b will represent the initial value and this m would represent the constant value. This b is also termed as the y-intercept. Y-intercept is the point where the graph touches the y-axis. So a couple of points over here. For this function, our m is 83 and b is 250. And you can see that the y-intercept is at 0, 250. And that's the magic of linear function. So when you see a line on a graph, you can bet there is a linear function behind it, guiding the way. That's it for this video, and I'll see you in the next one. Now, let's get to study.